Alrighty guys, here we go. What is our general process for solving a rational inequality? Now if you think back to quadratic and polynomial inequalities, we always went through and we tied it to a graph, but we haven't learned how to graph a rational function yet. And graphing a rational function is going to be even more complicated than solving a rational inequality. So we're going to go through and use a numerical process instead of a graphical approach. Okay, so this is our step-by-step process. So step one. We want to go through and we want to make sure that we have a single rational expression on one side and 0 on the other side. So the first two examples you look at will already be in that setup, but then we'll see two more examples where we need to do some rearranging and getting a common denominator to accommodate that. Okay, so once we have that, we then want to identify, do we want positive or negative results out of this expression? Okay, so we're going to take a look at the rational expression, compare it to the inequality sign, and identify, do we want that to be positive or do we want that to be negative? And I will walk through that on every example that we do so that you understand what I'm talking about there. Okay. Then we want to identify, well, what are the domain restrictions? These would cause breaks in a graph, and you'll find out more about that later. But they would make the function undefined, which can't be positive or negative or 0, so it's an issue spot. It's a number that you can't plug into the function, okay? Those will always be represented with open circles because x can never actually equal those numbers, all right? So those are our first three steps. Then we're going to take a look at what would make the numerator equal to 0. These are going to turn into x-intercepts on a graph, but they are the things that allow the entire expression to be equal to 0, because 0 divided by some other number, like 5, comes out to 0, and we want the expression to be 0 in most cases, okay? So we do the numerator equal to 0. Again, that would create an x-intercept. We'll talk more about that later. Those numbers on a number line could be either open circles or closed circles. Depends on if the inequality has an equal to in it or not. All right, so if there's an equal to, numerator will be a closed circle. If it's not an equal to, numerator will be an open circle. Okay. So then we're going to draw a number line, mark these values, draw the appropriate circles, and we're going to pick numbers from each section of the number line, the intervals, and test them to see, do they work or do they not work in the original inequality? And that's where knowing if we want a positive or a negative will come into play. And again, every example will walk you through this very carefully, step by step, okay? So don't worry if it doesn't make sense yet. Watch that first example and it'll probably start to make a lot more sense. Once I go through and test all these numbers and see what gives me positives, what gives me negatives, I choose my final answer and write it in interval notation. So that's with the parentheses and the brackets. So you'll get some practice with using that interval notation again. Okay? All right. Look for the other videos that walk you through the different examples. Good luck.